Welcome back. Today's goal of this lecture is, today I will see what is the span of a set, what is the linearly independent dependent of a set, and dimension of a set. This is our goal of this lecture. Actually, I had discussed in my previous video this topic elaborately obviously, but today I will discuss some question based on this concept. So at first I will highly recommend you, if you don't see my previous video, then at first see my previous video. Then today's question and today's concept would be very clear if you see my previous video. Just recall, what is the span of a set? If B be the subset of vector space, then we define span of B equal to set of those elements C1 V1 plus C2 V2 up to Ck Vk, where this vector P1 B2 Vk belongs to the vector space and C1 C2 Cn be actually member of the field. This is the span of the set. That means span of the set is actually collection of linear combination of the vectors which contain vector space. This is the span of a set. We all of us know this topic because this topic I have discussed in my previous video. For example, consider the subset B equal to 1x, x square, x cube. This would be continue, which is actually all power of x. Here 1 means x to the power 0, which contain all polynomial. Here notice by this set we can make the polynomial 1 plus x plus x square, 2x plus x square. That means actually all polynomial we can make with this vector, linear combination of with this vector. So obviously tell span of B is actually whole polynomial. So we are going to say by definition vector space of all polynomial spanned by this subset B. We are going to say vector space of all polynomial spanned by this subset B. Have you understood the concept? Actually today I will discuss some question, but if you don't know this concept clearly, then this will not understand the question in better way. So I have tell you again. But if we take 1 plus x plus half x square plus 1 over 3 factorial x cube plus 1 over 4 factorial x to the power 4, and this keep going on. This is actually the function e to the power x. My question is, e to the power x belongs to the set span of the set B? No, because spanning set always be linear combination of finite set. Have you understood? This is all linear combination of finite set. So to the power x does not belongs to span of the set B, because span of the set is always be the finite collection, finite linear combination. But here notice the linear combination of x is going on. So we cannot tell e to the power x be member of span of B. Have you understood this concept? Okay. Even though this set B contains infinitely many elements, but to make any particular element of the polynomial used finitely many linear combination. Okay? I hope my all viewers have understood what is the idea of span of a set. Now my question, is the set is linearly independent? Here linearly independent means this does not mean C0 plus C1x plus C2x square. This would be continue equal to 0 solution, because we all of us know the definition of linearly independent. If the set B contain the vectors v1, v2 up to vk be any finite number, this set is linearly independent if there exists scalar c1, c2, ck belongs to field such that c1 v1 plus c2 v2 up to ck vk equal to 0, where this c1 equal to c2 equal to up to ck equal to nothing but this is actually the trivial solution. This is the definition of linearly independent. Okay, that means to prove the set is linearly independent, we have to prove c0 plus c1x plus c2x square up to ck x to the power k equal to, here 0 means 0 polynomial, and for linearly independent we have to prove c0 equal to c1 equal to up to ck equal to nothing but this is actually trivial, means 0. For this, just put x equal to 0, then I will get c0 equal to 0. Then after derivative, if we derivative this polynomial, then c0 would be vanishes, then I will get c1 plus 2c2x, this would be continue, then I will get, if the polynomial is denoted as px, then up p prime 0 would be equal to c1. If this is equal to 0 polynomial, then that means I will get c1 equal to 0. Similarly, if we continue this derivative, then at last I will get p to the power k. Get derivative at the point 0, I will get ck, which is equal to 0. That means c0 equal to c1 equal to ck equal to 0. So this set is actually linearly independent set. Have you understood? That means set of polynomial actually also linearly independent set. And the idea of the basis is the subset B which contain the vector space is called basis if span of B equal to whole vector space and this subset B is linearly independent. As for example, consider polynomial and the set 1x, x squared, x cube, so on would be the basis of set of polynomial, and this is actually the standard basis because any polynomial can be generated by this set, finite collection of this set. Also, we all of us know this set, few minutes ago I have seen this set is linearly independent. So this is the standard basis of polynomial. Now I will discuss some question based on this concept which had come in different type of competitive exam. First question, which had come CSIR NET June 2013 exam. The question is, consider A be 10 cross 10 matrix. That means here the vector space is 10 cross 10 matrices with entries complex number because here the field is complex, and W be the subspace which is spanned by the set a to the power n where n greater than equal to 0. That means the subspace generated by I, a square, a to the power n, so on. Have you understood this subspace? And choose the correct statement. For any matrix A, dimension of WA less than equal to 10. Is this option is true? Option 2, for any matrix A, dimension of WA strictly less than A. Option 3. For some matrix A, dimension of WA greater than 10 and less than 100. And option 4 indicate for some matrix A, dimension of WA equal to 100. So option is true. This is just basic question and just basic concept. I hope my all viewers have understood which option be true. Let's check again. Here the concept is the characteristic equation. Since here given the vector space is 10 cross 10 matrix with complex field, we all of us know the characteristic equation would be such of n cross n matrix would be such type: x to the power n minus lambda 1 x to the power n minus 1 plus lambda 2 x to the power n minus 2 plus this would be continue plus minus 1 to the power n lambda n, where obviously lambda k means sum of all principal minors of order k. We all of us know lambda 1 is trace of the matrix and lambda n implied determinant of the matrix, and all other lambda k is the sum of all principal minors of order k. Also here we will use another concept, Cayley-Hamilton theorem. We all of us know Cayley-Hamilton theorem states every square matrix satisfies the characteristic polynomial. These two concepts will used here. Have you understood how we have to use these two concepts? Okay. By this rule, since here given 10 cross 10 matrix, therefore the characteristic polynomial would be such type. Okay, this is equal to 0 polynomial, and by Cayley-Hamilton theorem, since every matrix satisfies the characteristic polynomial, then this would be e to the power 10 minus lambda 1 e to the power 9 plus lambda 2 e to the power 8. This would be continue plus minus 1 to the power 10 lambda 10 identity equal to 0 polynomial. That imply e to the power 10 equal to lambda 1 e to the power 9 minus lambda 2 e to the power 8. This would be continue, and here plus minus 1 to the power 10 lambda 10 identity. That means here by this expression we can tell e to the power 10 is linear combination of the set e to the power 9 comma e to the power 8 comma identity. Okay, and since w equal to span by e to the power n, where n greater than equal to 0, that means w span by identity a square e to the power n, and this would be continue. That means since I have got a to the power 10 is linear combination of these vectors, similarly multiply this equation by a, then I will get e to the power 11 equal to lambda 1 to the times e to the power 10 minus lambda 2 times e to the power 9, and this would be continue, and here would be minus 1 to the power 10 times lambda 10 times a. And here since a to the power 10, so just put the value here. So if we put the value here, then you will get a to the power 11 also is linear combination of a to the power 9, a to the power 8. This would be continue, and here would be identity. Similarly, I will get a to the power 12, a to the power 13, all be linear combination of this vector. Here in the question has given w be the span of a to the power n, where n greater than equal to 0. Here I have got this wa actually spanned by a to the power 9, a to the power 8. This would be continue identity. And if all vector be linearly independent, then dimension of WA would be 10. But if this is not all be linearly independent, then dimension of WA would be less than 10. That means here the option is dimension of WA would be less than equal to 10. Have you understood this question? That means which option be true? For any A, dimension of WA less than equal to 10. And option 2 indicate for any matrix A, dimension of WA always strictly less than 10. When all vector be linearly independent, then dimension of WA would be equal to 10. So then option 2 obviously would be wrong option. And option 3 obviously wrong option, because here has indicate dimension of WA less than 100. This is not possible. And option 4 also wrong option, because here has indicate dimension of WA equal to 100. This is also not possible. That means only option 1 is a right option. Have you understood this question? Okay. Now I will see similar type of question which had also come June 2022 exam CSIR net. The question is CB n cross n real matrix, and here the subspace is denoted as identity C square C2 to the power 10. Similar to before, here only n cross n matrix, and before has indicate 10 cross 10 matrix. Then dimension of this, we all of us know spanning set be a vector space also. So dimension of this spanning set means this vector space. Option 1 to n, option 2 at most 10, option 3 n square, option 4 at most 2n. Here the CB n cross n real matrix, so obviously the characteristic equation would be lambda to the power n minus a to the power n minus 1 lambda to the power n minus 1 plus a to the power n minus 2 lambda to the power n minus 2 up to minus 1 to the power n a0 I. Therefore, by Cayley-Hamilton theorem we can tell this matrix also satisfy this characteristic equation. So by Cayley-Hamilton theorem this satisfy this equation. So c to the power n equal to this equation. That means c to the power n is linear combination of identity c square c to the power n minus 1. And here the given set is identity c square c to the power 2n. So the set identity c square c to the power n minus 1 also span W, and if this set be linearly independent, then dimension of W equal to n, otherwise dimension of W would be strictly less than n. Therefore we can tell dimension of W at most n, and that imply dimension of W is also at most 2n. Not to before, option 2 is the right option, and since here has indicate at most n, so we can tell obviously this dimension also at most 2n. So option 2 and option 4 is the right option. Have you understood? The question actually very conceptual question. First question and second question are all same. In first question has indicate 10 cross 10 matrix, and second question has indicate n, just n cross n matrix. This is just difference. And here in first question W spanned by a to the power n where n greater than equal to 0, but in second question here W spanned by identity c square c to the power 2n. Have you understood? Just similar type of question. So actually concept is very important. I hope my all viewers have understood this concept in better way. Okay? Well, now I will discuss one question of CSIR net which had come in June 2015 exam. The question is actually the spanning set which I had discussed our beginning of this lecture. The question is Pn x equal to x to the power n. Now I have cleared what is the Pn x. This is span of 1x x square, so on. Then the question is option 1. P is a vector space of all real valued continuous function on the real number. Option 2. P is a subspace of all real valued continuous function on R. Option 3. The set P0, P1, P2 is linearly independent set in a vector space of all continuous function on R. Option 4. Trigonometric function belong to this set P. I hope my all viewers have understood which option be clear, because I have discussed every topic in the beginning of lecture. Just see again. Here first option P is a vector space of all continuous function on R. Told you spanning set always be vector space, but if consider the vector space V equal to spanning of the vector u1, u2, un, that means the vector space V is finite linear combination of these vectors, and this set, this spanning set generates a vector space if for every V belongs to the vector space V can be written as uniquely as a linear combination of this vector. Here this is very important. This set be vector space when every vector of the vector space can be written as uniquely as a linear combination of the vector ui. That means here the given set is Pnx equal to x to the power n. Here the given set is spanning set of 1x x square, and since spanning set is always be finite, that means this combination would be C0 plus C1x up to Ck xk, where k be any finite number. We all of us know mod x always be continuous function on R. If mod x be continuous function on the set R, and since here the P is the spanning set of this linear combination, that means mod x equal to such type C0 plus C1x C2x square plus Ck x to the power k, since here finite number of linear combination always for spanning set, where k be any large number, that imply C1x equal to mod x, and that means C1 equal to plus minus 1. That means this function mod x cannot be uniquely written as linear combination of the element of this set. That means mod x obviously continuous function. So this set be not vector space of all continuous function. Actually this set generate every polynomial. So this is actually the subspace of all real valued continuous function on R. That means option 2 is the right option and option 1 is the wrong option. And notice option 3, here P0, P1, P2 is linearly independent set in a vector space of all continuous function on R. Why this set is linearly independent always? This concept I have discussed beginning of this lecture. So third option is always right option. Option 4 indicate trigonometric function belongs to this set P. In the beginning of the lecture I had seen e to the power x does not belongs to this spanning set P, because e to the power x means there exists infinite sum. Similarly, here the question about trigonometric function, if we consider sin x, then this sum equal to obviously infinite sum. So obviously sin x does not belongs to the set P, because spanning set means always linear combination of finite set, but this is infinite sum. So as well as e to the power x, all trigonometric function does not belongs to this set. Only polynomial function is belongs to this set. So this is subspace. Also this set is linearly independent.
Option 4 is a wrong option.
I hope my all viewers have understood why I have told you many times actual definition, concept. This part is very important to understand any question in proper way. Okay? Oh well. Today I will stop here. And if you helpful this video, then please subscribe my channel and share this video to your friends and all math lovers. Okay? See you soon. Stay safe and stay positive always. Thank you so much.